Hello guys, it's Dr. AJ. So we have three examples today on the bearing capacity. It's a really important topic in the FE and the PE exam. So let's get started. The first example, as you can see, we have strip footing. The width is given 4 feet. They're going to build it on the ground surface. This is a key word. Beneath the footing, we have a sand soil. This is the second keyword. So at first, the footing basically is going to be on the ground surface. That's very important. And the second thing, we have sand soil, not clay. The bearing capacity factors NC and gamma and NQ are given to you. The unit weight for the sand soil is given 140 PCF pound per cubic feet. Please pay attention to the units. And they are looking for the ultimate bearing capacity. So as usual, we start by writing down what is given. So the depth of the footing is 0, because as we said, on the ground surface, gamma sand is given 140 PCF, and then those are basically the bearing capacity factors that we're going to be using. And we're looking for the ultimate bearing capacity. You go to the FE reference manual, you're going to see this is basically the equation for the ultimate bearing capacity. So the first term is basically for the cohesion. The second term has relationships to the depth of the footing. And then the final one is basically for the unit weight for the soil. So we write down the equation. Please pay attention to the gamma. The gamma written here is gamma effective. But since we don't have water, the gamma for the soil, the gamma total is going to be equivalent to the gamma effective, which is in this case 140 PCF. So C is 0 because, as we said, it is sand. So the entire first term is gone. The second term is gone as well because DF, the depth of the footing, is 0 because, as we said, it's on the ground surface. So we're going to end up having only one term. So half, gamma is 140, B is 4, and 25 is the N gamma. And that's going to give us basically 7,000, which is answer B. So example 2, we have a spread footing. Factor of safety is given 2.5, and then the allowable bearing capacity is given as well, 418 PSF pound per square foot. What is most nearly the minimum net bearing capacity of the footing? So from DAS is basically one of the soil mechanics books. It's very famous, and I suggest everyone wants to take the PE exam, just get this book. It's very helpful and easy really to follow, and there are quite a few examples in the book that helps you master the geotechnical part of the exam. So from equation 1618, you can see the Q allowable is basically the ultimate bearing capacity over the factor of safety. There are basically two Q allowable. The first one is the gross, and it's equivalent to the Q, the ultimate bearing capacity, the gross divided by the factor of safety. The second one is the net, and it's the same as the first one, but the only difference is the ultimate bearing capacity in the first case is the gross, the second one is the net. So what's the difference between the gross bearing capacity and the net bearing capacity is basically the soil effect, the pressure that comes from the soil. When we say it's net, is basically we're trying to exclude the pressure that comes from the soil, the one that is on top of the footing. So the ultimate is basically the dead and the live that comes, because you have the footing, and the footing basically is supporting column, right, which is part of the building. So live load and dead load comes from the column itself. And then you have the weight of the footing itself, because we have to calculate that. And then there's a weight of soil which is on top of the footing. So when you say QU gross, which is the ultimate bearing capacity, that means we're trying to include the load that comes from the column, the load that comes from the weight of the footing, plus the pressure or the weight that comes from the soil. When it comes to the net ultimate bearing capacity, we're just trying to exclude the pressure that comes from the soil. So in this case, QU net is given in hour. So the Q net is given. Q allowable, I'm sorry, Q net is what we're looking for. Q allowable net is given. They did not say it's net, but since the Q net is what we're looking for and we don't have any other parameters that help us to determine whether it's net or not net, we're gonna assume it is net, Q allowable, and the factor of safety is given. So just as a quick, as we mentioned, so this is the QU net is basically, as I said, is the QU minus the Q. The Q is basically the effect of the pressure that comes from the soil, which is gamma times the depth of the footing, because you got the depth of the footing and then there is soil on top of it. That's why we use the depth of soiling. Gamma is basically the gamma of the soil. So we subtract that from the ultimate, and this is the equation of the ultimate. Has the CNC, Q and Q, and half gamma being gamma. This is equation 1611, 1620, and 1621 from the same book. So we go back to the question, Q allowable, here it is net. It is given, 418 PSF, factor of safety is given, Q net is what we're looking for, and Q net is basically Q ultimate net. That's what we're looking for. So Q allowable is basically Q net over the factor of safety. Q net is what we're looking for. So in this case, it's going to be Q allowable times the factor of safety. 418 times 2.5, it's 1045. And since the options, there is no 1045, the closest thing is 1040, so the answer will be A. Example 3, they're looking for the soil density. The ultimate buried capacity is given 500, cohesion is given 15, the units are SI units, so please guys pay attention. Angle of internal friction is 20. The depth and the width of the footing are given as well, 2 meters and 1.5, and we're looking for the gamma soil. This is a purely PE question. Why? Because we're going to be using a table that is not given in the FE reference manual. So for the FE people, it is, you can just understand what's going on. It helps, of course, but it is definitely a PE question. So as usual, we start writing down what is given, the ultimate depth and width of the footing. We have the cohesion and phi, the angle of internal friction. So this is basically the ultimate bearing capacity equation. We went to the FE reference manual, we got the equation. As you can see here, the bearing capacity factors NC, NQ, and gamma is not given, but what is given is angle of internal friction. So that helps. So if you go to the table 16.1, Terzaghi bearing capacity factors, and you check since we have a phi, the angle of internal friction, it is, and the source again is, as I said, Principles of Geotechnical Engineering by Das. This is the book, very useful and very helpful. So since we have angle of internal friction, we're going to be able to find NC, NQ, and N gamma from the table. Those are the numbers 17, 7.4, and 3.64. So this is the ultimate bearing capacity equation. We write it down. 500 is given. 15 is the C. 17.69, we just got that from the table. Gamma is what we're looking for. Again, gamma effective is the same as gamma total since we don't have water. 2 is the depth of the footing. NQ, we got that from the table again, 7.44. Half is from the equation. Gamma is what we're looking for again. 1.5 is the width of the footing, and N gamma is basically 3.64 from the table. So we do a little bit mathematics, and then we're gonna get a gamma of 13.3, and it's almost 30, so that's gonna give us option A. With that, thank you very much and see you next time.